Hello, learners. Welcome back to Constant Learners. We are continuing with our series on DBMS, and today's video will be the three schema architecture of database management system. All right. So, in this first, we will discuss the three schemas, that is, external schema, conceptual schema, and physical schema. Right. Then we will discuss the concept of data abstraction and data independence along with its types. All right. And then finally, we will discuss the concept of data mapping. All right. Let's begin. Now, schema. What is schema? Schema is nothing but the structure, the logical representation of the database. It signifies how the data will be stored in the database, what the structure of the database will be, and the relationship between the data. Right? Now, in every previous video that we have discussed in database management system, we have always taken the example of relational databases, right? Where the data is stored in the form of tables, and all of this data is somehow related to one another, right? That is, the tables are related to one another. So, declaration of these databases, the tables, the columns, primary and foreign key, how the data will be stored inside each table, inside each column, whether it will be an integer or a character, what should be the length of data inside each cell. All of these are decided in the schema or the structure of the database. All right. I hope that this much was clear. Now, why exactly do we need a three schema architecture? See, the user is sitting here. All right. And the database is here. So, the user wants to access the data inside this databases. If you see, we have three different levels between the user and the data. So, what exactly are we trying to do? We are trying to completely separate the user application from the database, right? So the data will be continuously available for the user. Whenever the user wants to request or access some kind of data, it will be made available to him. But what is the physical location of the data? What is the access path? Which file is the data stored in? That is not accessible to the user. The user is unaware of how the data is being stored. What is the structure or schema of the data? The user is unaware of all of this information, right? Now, since we have three levels here, that is external schema, conceptual schema, and physical schema, we call it a three schema architecture. All right. Now, let's discuss each of these schemas in detail. So, the first one is external schema, right? External schema is something that the user sees on the screen. For example, the Instagram app. When we open the Instagram app, we see some data on the screen. We see the posts from other people, we see other people's stories, we can see our own posts, our profile, other people's profile. So there's something that we are seeing on the screen. Similarly, if we talk about WhatsApp, when we open WhatsApp, we can see the chats of the people that we have spoken to. We can see new contacts. We can look at the previous calls, the recent calls. We can view their statuses, right? So all of this, whatever we are seeing on the screen, is the external schema. It is something that the user sees on the screen, right? So the PHP or the Java developers, they work hard to create a front end for the user's view, right? Now you can see that there are multiple external schemas. This is one external schema. This is another external schema, and we can have multiple, three, four, multiple external schemas, right? Why do we have multiple schemas? Because different users have a different view of data, right? Let's take an example of food delivery app, right? What happens? I'm sure you must have used Zomato or Swiggy at some point in your life, right? What happens? We as a customer, we have our app, the Swiggy app or the Zomato app. We open the app. We can look at different restaurants. We can look at different cuisines, menu, the offers that we are being offered, right? So that is our view of data as a consumer. That is our view of data. However, if we talk about a vendor, that is, if we talk about a restaurant owner who has registered himself on Zomato or on Swiggy, then they will have a different view of the food delivery app, right? That person will be receiving orders from the customer, and the vendor will have to complete those orders and dispatch the food. So his view of data will be different. What he will see on the screen will be the orders that he has received, the time that will be required to complete those orders, whether the food delivery person has arrived or not, whether the food has been given to the food delivery person or not. All of that information would be viewable on the restaurant's app, right? So their data, their view of data will be entirely different from the consumer's view of data. Similarly, if we talk about a food delivery rider or the person who is delivering the food, then he will have an entirely different view of data. What he will view on his screen will be that he is receiving a delivery order, which restaurant does he need to pick up the food from, which area or which customer does he need to drop the food at, the package at, right? So this is what he will view on his screen, right? So every user will have a different view of data, and that is why there are multiple external schemas, right? Every user will have a different view of data. Similarly, if we talk about the person who is sitting as an admin, who is coordinating all of these people, that is the consumer, then the food delivery rider and the restaurant. So there has to be some person who is communicating with all three of these people, trying to keep everything synchronized, right? So he will have an entirely different view of data, right? Thus, we can say that there are multiple different external schemas depending upon the requirement of the user. So the first level or first schema is external schema, which is nothing but the view level. It is also known as view level, right? And this view is different for different groups of people, right? And only the data that the user is interested in will be made available to him, right? Similarly, if we talk about a college database, then in that case, multiple people will have multiple different views of data. The admin department will be focused more on the fees that has been paid by a particular student or not, which field or which course is the student enrolled in. Then that will be their view of data. Then if we talk about the librarian, he will have a view wherein he will be able to see which books have been issued by which student. The professors will be able to view the attendance, the marks, assignment submission of each student, right? So everyone will have a different view of data, and that is the external schema. All right. Now it is good to have multiple different schemas, multiple different external schemas, that is multiple different view of the data. Why? It prevents unnecessary data from the users that don't need them. So something that I don't need or I don't require, that will not be visible to me, right? And it also helps with the security purposes, because not everyone has the permission to view all of the data or modify all different kinds of data. The librarian will only be able to modify the data related to the issue of books. The admin will only be able to view the fee related and finance related information about the student, right? This ensures security and authenticity of the data. I hope that external schema was clear, right? The next is logical schema or the conceptual schema. Conceptual schema is also known as logical schema or logical level or logical view of data, right? Now, this describes the storage structure of the database, right? Storage structure means what? That is the structure of how the data is being stored inside the database, right? Now, we are not talking about the physical storage of the data. We know that the data is stored inside the database in a particular format. For example, with relational databases, the data is stored in the form of tables, right? And these tables are related to one another. The data inside each of these tables is related to one another. So database designers, they sit together at this level to decide how many tables should be there, what data should be stored inside each table, what should be the columns, how many rows should be there, how should the tables be related to one another, because there's going to be multiple different tables, right? So how are these tables going to be related to one another? What are these tables going to represent? What kind of data is going to be stored inside each of these tables? What kind of data will each of these columns hold? All of this is decided in the conceptual schema. All right. This is kind of the blueprint of the entire database design, right? As we've already discussed, it is not about the physical storage of the data. This is more about conceptual or logical storage of the data. It focuses more on describing the entities. Entities are nothing but the tables, right? The data types, constraints, relationships, columns, etc. All right. So logical schema is all about the tables and the structure of the tables and the relationship between the tables and how the data is being stored inside each of these tables. So that was conceptual or logical schema. Now, next one is the physical schema, right? Physical schema is also known as physical or internal level, right? This actually describes the physical storage of the data. That is, where exactly is the location of the data. That is actually where the data is being stored, the physical location of the data, whether it is in United States of America, whether it is in UK, whether it is in India, Africa. So this physical schema actually represents or contains information about the physical location of the data, right? The database administrators take care of this task. So in conceptual schema, that is this one, in the second schema. In conceptual schema, we were talking about the logical view of the data, right? That is, what kind of tables will be there, what columns will be there, what kind of data will be stored in each column. But in case of physical schema, we are actually talking about the physical location of the data, right? And even though we are viewing the data in the form of tables, it is not actually the case of how the data is stored, right? Physically, the data is not being stored in the form of tables. That is just our view of data. It is what we are seeing, right? The data is actually being stored inside the files only. So what kind of files is the data being stored? That is the information that is stored in the physical schema, right? Physically, the data is not being stored in the form of tables. It is stored in files only. However, the tables, we are able to view the data in the form of tables in logical view of data, right? But the data is actually stored in the form of files only. The tables are only our view of data. That is how we are viewing the data. That is how we want the data to be segregated or separated and related to one another, right? And physical schema actually stores the location of these files where the data is stored, right? Along with the data inside these files. So physical schema stores the data as well as the physical location of the data along with its access path. That is, which directory or which folder, that is folder 1, then folder 2, then here we have, let's say, the file is stored. So all of this entire access path, the location of the data, all of this is stored inside the physical schema. All right. So even though physical schema stores the physical location of the data, the user has nothing to do with it, right? The data is constantly available to the user, but he is not aware about the physical location or the structure or the physical structure of the data. He requests the data and his requests are fulfilled, and whatever data is being requested for, he gets that, right? So the user is unaware of the physical location of the data or the logical view of the data. The user has nothing to do with it. He will only make a request and that data will be made available to the user, right? So this gives rise to the concept of data abstraction and data independence. All right. Now, I hope that these three schemas, that is external schema, conceptual schema, and physical schema, was clear, because now we are going to hop on to the concept of data abstraction and data independence. All right. Now, data abstraction. Now, as you can see, the user and the data are far away from each other. There are multiple layers between the user and the data. Just like when we post something on Instagram, we can view the data. We can view our posts whenever we wish to and from wherever we wish to. We can view other people's data also, whatever is made available to us, right? But the user is unaware of the exact physical location of where our data is being stored. Similarly, on WhatsApp, we have our chats, right? We have our private personal chats with different people. That is our personal data. That is our property, right? And we have it available to us whenever we wish to, but we do not know the exact physical location of that data, right? That is, the data is constantly available for the users, but the users are unaware of the complexities of how the data is being stored and how it is being managed, right? As we have seen in the physical schema as well as in the conceptual schema. In conceptual schema, we believe the data is being stored in the form of tables, right? But in physical schema, we say that the data is being stored in the form of files. So the way the data is being stored and the way it is being made available to us, these are two entirely different concepts, right? This is what we need to understand, that the data is being stored in a format in the physical location in the form of files, but the view that we have of the data is entirely different. All right. So that is data abstraction. That is, the user is unaware of the physical location of the data and the complexities of how the data is being stored and managed. Right. Then next is data independence. Then what is data independence? In data independence, if let's say one schema requires any changes, right? We do not need to change or modify the other schema. That is, if I wish to change the external schema, I do not need to make any changes in the conceptual schema. Similarly, if I wish to change something in conceptual schema, it is not necessary that I'll have to change the front end also. Or if I wish to change something in physical schema, that is the location of the data or the files in which the data is being stored, we do not exactly need to change the conceptual schema. That is not required. So here, the concept of data independence means what? That if we are changing one schema or one level, we do not need to modify or change the other schemas. This is known as data independence, right? Now, there are two types of data independence. The first one is the logical data independence. The logical data independence lies between these two here, that is external schema and conceptual schema. This is also known as logical conceptual view of data. So, what does logical data independence say? Logical data independence says that if conceptual schema changes, that is, if we wish to change the conceptual schema, we do not necessarily have to change the front end or the user application. Alright, we do not need to change the external schema if we wish to change the conceptual schema. We can make the changes in the conceptual schema, that is the tables, the columns, the type of data, the constraints, the relationships. We can modify that without changing the front end or the user application. Alright, I hope that logical data independence was clear. Second is physical data independence. What happens in physical data independence? Physical data independence lies between conceptual schema and physical schema. It states that if we wish to modify the physical schema, we do not necessarily need to modify the conceptual schema. Okay, that is, we can change the physical structure, the physical location or access path of the data without changing the conceptual schema. Alright, that is without changing the tables or columns or constraints. So until and unless the data itself or its placement or columns or constraints are being changed, we are not modifying the conceptual schema, but we can surely change the name of the files where the data is being stored, its location, its access path, etc. Alright, so that was data independence. I hope that up until here everything was clear. Now the last concept that we need to discuss is mapping. Right? Now when a user is making a request to the let's say user application for some kind of data from the database. So that request first goes to the external schema, right? That is the front end of the application. which is then moved to the conceptual schema, right? This request then goes to the conceptual schema, right? And finally, the request goes from conceptual schema to physical schema, right? And then from here, the data is extracted and returned to the user. And this data is also returned in the exact same format. That is, from the database, the data first goes to the physical schema. From physical schema, it goes to the conceptual schema, and from conceptual schema, it goes to the external schema. That is, finally, the data is being made available to the user, right? So when the request is moving from external schema to conceptual schema, that is, in between these two schemas, we call it external conceptual mapping. All right. And when the request is moving from conceptual schema to physical schema, or vice versa, that is between conceptual schema and physical schema, we call it conceptual physical mapping. All right. I hope that until now everything is clear. For example, we all use WhatsApp, right? On WhatsApp, if I'm looking for a particular contact, I will go to the search option, type the name, and that particular contact will be visible to me, right? So on the front end, I'm using WhatsApp to search for a particular contact, right? That request is going to the conceptual schema over here, right? That is, I'm searching for this particular contact. So in the tables, the data that I'm looking for is located. Once the data has been located, the request then goes to the physical schema. That is, the data is then extracted from the physical location of the database, right? From where the data is extracted and made visible to the user, right? So this is how the three schema architecture of database management system works. I hope that all of it was clear to you. That was all for this video. If you have any doubts or queries, please mention them in the comment section below. I will make sure to respond to them as early as possible. Share this video with as many people as you can. Subscribe to the channel. Thank you so much for watching.